presentation this morning, I'm not going to tell you what our company is until the end because it's far too complicated and it'll spoil the show a bit, so bear with me for a bit on that one. It was interesting to know this morning a lot of products that were mentioned, and also we just heard a presentation on a service, but what we're looking at is the tools and processes that actually deliver those actual products and processes. So what I'm going to try and do this afternoon is give you a bit of an insight, if you like, into the importance of developing those tools and processes and why we need to do it. And what's interesting is that we need to develop more efficient products. I mean, there's a lot of this word I've learned today, decarboning, which I'm going to see if it's in the word spell checker. But it's easy to forget that you need to look at decarboning the actual design process itself, because there's a huge amount of energy used in actually designing products, and that's something we need to look at. And so hopefully then when we get to the delivery part of the presentation, you'll actually understand what our company does. CFMS's initiative actually started off in the aerospace industry back in around 2004. The European aerospace industry recognised the importance of the environmental issues way back in around 99, 2000, somewhere around then. And there was an initiative called ACARI, Advisory Council for Aeronautical Research in Europe. This was an initiative set up by the aerospace industry as sort of preempting potential punitive charges on the air transport industry. And they deliberately set themselves very challenging targets to improve the environmental impact. There's one thing, there were other things such as security and reliability. But one of the big things was the environmental impact of aviation. And they signed up for some very, very challenging performance improvements, such as 50% reduction in CO2 by 2020. Very laudable, but unfortunately they didn't ask engineering if it could actually be done. Which meant that what we had to then deliver was the so-called game-changer aircraft. The bottom line is, if you look at your Airbus aircraft, your Boeing aircraft, if you look at your Rolls-Royce engine, they're already very, very efficient bits of kit. And to improve that by 50% isn't easy. And so we looked at the tools we had, the technologies we had to actually deliver that improvement. And the bottom line was, we needed a step change in their capability. So to go with the game-changer aircraft, we also needed game-changer tools and processes. And it didn't take long to work out that that challenge was actually faced by an awful lot of other industries as well. So if you look at marine, it's interesting that the presentation this morning didn't actually show the sort of shipping industry contribution to CO2, which is absolutely huge. And I deliberately found the grottiest looking smoke coming out of a ship's funnel. But it's actually very important, and it's something that is rapidly increasing in awareness, the amount of emissions that come out of these ships. Automotive, we heard a lot this morning about electric vehicles and so forth. But what's interesting is a good example in the motorsport business. We don't think about motorsport as a particularly environmentally friendly activity. But if you look at what those people want, they want to maximise the energy they get from the fuel on board that car. They almost take it to the point of obsession. So although they're facing a different challenge, they're trying to get the absolute maximum out of the fuel they carry. And there's a lot we can learn from what motorsport people do in terms of normal everyday cars. And then again, we've heard a lot about power generation this morning. Similarly, not just looking at conventional systems, but also renewables. They all need to be designed. So we've got to develop tools and processes that do a range of different things. We've got to actually look at making a more optimised product, but also it's got to develop a product that is potentially a lot more complex, but also look at improving the process efficiency itself. So how are we going to do that? This is all about developing a better product, and this is what we're trying to investigate. How do we do that? So the first thing you've got to do is unlock design potential. You've got to look for innovative solutions. The bottom line is, if you're going to achieve a 50% fuel burn reduction, it's hard, it's not easy, it's not something that you're going to do very simply. So what you've got to do is make the design process much more powerful. It's got to be much more intuitive, and it's got to be much more effective. So you've got to be able to investigate novel design solutions. You've got to be able to investigate the design space outside of your experience. So in other words, you've got to start looking at solutions that you haven't looked at before. And what you've got to do is focus on the actual value-add activities. So move away from all the sort of traditional number crunching and actually focus on exploring the design space. The other thing you've got to look into as well is much higher fidelity in terms of the numerical simulation. You've got to have confidence in the solution. So if you're exploring the design space, if you're going into corners of that space that you've never been in before, if you're not going to have the luxury of a prototype or experience, what you've got to do is have confidence in the solution. And how do we do that? At the moment, we don't know. How do we give people the confidence in the solution that comes out of it? The sort of thing there, I mean, we have to look at, an interesting example again from the aerospace industry, is Rolls-Royce engines, where they're going to have to simulate the entire life cycle of an engine. It's no good now just selling an engine that works well when it's brand new. That engine's got to last 20, 30 years and perform as well then as it does now. That's not something that you can do with traditional testing methods. We need to simulate that. And finally, optimization. The people make a career out of optimization. It's something that's been talked about for years and years and years, and we still don't do it. We still have organisations where you've got individual departments looking after aerodynamics, structures and everything else. The bottom line is we still don't optimise the product that we're going to make. So what we need to do is look at true optimisation technologies. But we need to look at a very, very wide range of parameters in there. It's no good just looking at one discipline. We need to consider things like the manufacturability of a product. It's no good making a product that has a superb environmental performance if it costs a fortune and therefore generates a lot of pollution to actually make. So what we need to do is we need to look at optimization processes and actually put parameters into those processes that really matter. Again, nice pretty pictures there that show the sort of the output you get from optimization. It is hard, it's not straightforward. And also it needs, at the moment at least, people who are very experienced in this field to be able to use it. We need to consider the user interface. A designer has to be able to use this simply and get the right answer out of it. And also, it's going to rely very much on effective interface between different tools and processes. And at the moment, what you find is that the way the industry is constructed, it almost works against things working together effectively. So research is needed. How do we actually get these things working together much more effectively than they do today? I think it's important to say at this point that we don't know how to do most of this at the moment, and that's a whole reason for us existing is to promote research in these areas to actually address some of these challenges that I'm posing today. So that's all about the sort of the right product, so looking at decarbonising the product, but we also need to consider the design process itself. If you look at supercomputers, they are very energy-hungry beasts. We need to get a lot more out of the systems that we use. So we need to start looking at a smart system. It's a phrase we coined recently that covers a whole basket of technologies, if you like. One important thing is using the right tool for the job. That might sound pretty obvious, but it's amazing how rarely that's done. What people tend to do is leap into probably the most complex design tool they can use. They think if it's more complex, it's better. The truth is, it's probably not the best. And what we need to look at is actually using the right tool. Why don't we reuse existing information? So let's reuse existing data. It's much more energy efficient to just retrieve data than actually generate itself from scratch. So how do we go about doing that? There's some interesting challenges about data reuse in terms of data standards, data formats, but also the actual hardware that the data is stored on. So again, there's research needed to understand how can we actually effectively reuse data. But also, the actual interface with that design process needs a lot of work. It has to be much more effective, so you don't waste time. And usually, if you're running an IT system like we're running here today, time is basically energy. So if we can reduce the amount of time you spend designing a product, we can reduce the energy it takes to do that. At the moment, it has to be said that most engineering design tools, and apologies if there's anybody here from an engineering design tool supplier at the moment,